Hello, my name is Campbell Garrison. Today I will be discussing my final project for ME303 Mechanical Measurement 1. So for my final project, I decided to do an experiment on the Arduino Uno circuit board using the thermistor device, as you can see. And the goal was to determine the delay time it took for the thermistor to register the output voltage due to the current temperature of the room. So in order to do that, what I did for the experiment was I stuck the thermistor into a freezer, which had a temperature of about 14 degrees Fahrenheit, and then put it into a room temperature room, which was at 75 degrees Fahrenheit, and recorded all the data points on the output voltage, as well as the resistance value that the thermistor presented. And then using that data, I was able to determine the time it took for the thermistor to record the output voltage of the actual room rather than the output voltage of the temperature that it was previously at the 14 degrees Fahrenheit. Now, in order to conduct this experiment, what we did was we designed a circuit board that was almost identical to the circuit that was used in the photoresistor lab earlier in the ME303 course. That circuit was then hooked up to the Arduino Uno board and then attached using a USB cord to the computer that was on a Arduino program. That program was almost identical as well to the photoresistor lab. The only change was the delay in time that presented the data values in the photoresistor lab was at 250 value, and that this current lab was at 1,000 value, so which is about 1 second. All that data showed up on a monitor on the computer, and it was unable to save it. So what we actually did was we used a QuickTime player recording device, and it recorded the screen, and then we went back and replayed the video and then converted that data manually into the Excel file for us to then analyze it. When analyzing the data from the Excel sheet, we immediately found an exponential decrease in the output voltage. We saw that the output voltage began to plateau and reach a steady state after 16 seconds. The output voltage did not reach a complete steady state until 3.5 minutes of recording data. Now, the values within this experiment are extremely useful for several reasons. Knowing that it only takes 16 seconds for a thermistor to begin to reach a steady state output voltage tells us that if we were doing an experiment that uses a thermistor, we would have to wait at least 16 seconds for the thermistor to calibrate to the room temperature before we can begin to record data points. Now, the data found in this experiment, specifically with the thermistor, is significantly different than that of the photoresistor experiment. This is due to the fact that a photoresistor can register darkness and lightness a lot quicker than it takes for a thermistor to heat up and cool down, especially going from 14 degrees Fahrenheit to 75 degrees Fahrenheit in a short amount of time. Now, I believe it would be interesting to do an experiment with a larger thermistor to see how that affects the time delay, due to the fact that it would probably take longer for a thermistor of a larger size to heat up or cool down, causing a longer time delay. Now, are there any questions in relation to the thermistor, the circuit board, the data found, or just the overall project for my ME303 class?